Today, we are looking at a living, breathing monument of biological engineering. This is an organism that has absolutely mastered the art of building itself straight into the sky. So let's dive into the incredible world of the Coast Redwood, the undisputed tallest living thing on planet Earth. And just to wrap your head around that scale, we're starting right at the very top. This is the height of Hyperion, the current world record holder. That is over 380 feet. It's taller than the Statue of Liberty, taller than a 35-story building. But you gotta remember, this isn't some inert structure. It's a living hydraulic machine that is operating at an almost impossible scale.
Okay, so one thing people always mix up is the difference between the Coast Redwood and its famous cousin, the giant sequoia. This table makes it super clear. The key takeaway is this. While the giant sequoia is the world's biggest tree by sheer volume, think of General Sherman, the Coast Redwood, Sequoia sempervirens, is the absolute master of height, specializing in that slender, record-shattering vertical reach.
And the reason they can reach these incredible heights is because they are masters of survival. I mean, their lineage stretches all the way back to the age of dinosaurs. These trees can live for over 2,000 years, and they do it protected by this fire-resistant bark that can be up to a foot thick. They are truly ancient architects, building their towers over millennia. But that incredible height, well, it presents a really profound biological mystery. And that brings us to one of the biggest challenges in all of botany. How in the world do they defy gravity?
So let's frame the core problem here. Think about this for a second. How does a redwood move hundreds of gallons of water from its roots all the way up to its highest leaves, day in and day out? It is a plumbing problem of epic proportions, and on the surface, it seems like it's just breaking the laws of physics.
Well, the standard scientific explanation is something called the cohesion-tension theory. Now, the most important thing to get here is that the water isn't pushed up from the roots like some kind of pump. No, instead, it's pulled from the top. Evaporation from these tiny little pores in the leaves creates this powerful tension that literally yanks the entire unbroken column of water skyward through microscopic tubes called xylem. But here's the catch. For every single meter that water has to travel up, it pays what you could call a gravity tax. The tension on that water column becomes absolutely immense. Up at 380 feet, the water at the top is under such extreme negative pressure, it's constantly on the verge of just snapping. And if that tension gets to be too much, you get catastrophic failure. It's a process called cavitation, basically the formation of tiny air bubbles that break that continuous column of water. For that branch, it's the equivalent of a fatal heart attack, completely cutting off the water supply for good. And this is where it gets really mind-blowing. Look at how close to the edge these trees are living. Scientific models predict the absolute maximum height a tree can possibly reach before its plumbing fails is somewhere between 122 meters and 130 meters. Hyperion, at 116 meters, is operating right at the razor's edge, the functional limit of life itself. So how does it survive? How does it push that boundary day after day? Well, it turns out the redwood has this ingenious workaround, a secret weapon that allows it to, get this, drink directly from the clouds. And here's the redwood's brilliant two-part solution. See, it doesn't just rely on its roots. Through something called foliar water uptake, its leaves can actually absorb moisture directly from that dense coastal fog. And even more amazing, through bark water uptake, its very own bark can drink in moisture and feed it right into that stressed-out water transport system. The impact of this is just profound. The tree isn't just getting a quick drink. It's actually performing active hydraulic repair. The water it absorbs way up in the canopy is used to fix those dangerous air bubbles, healing the highest, most stressed branches from the inside out, and keeping the water flowing right where it's needed most. And you have to understand this whole system is only possible because of their unique home. In a typical year, the redwood canopy is just bathed in fog for more than 1,000 hours. This constant supply of moisture from the air is the lifeblood that fuels their record-breaking climb to the sky. Now, this extreme height and incredible lifespan, they don't just create a tall tree. No, they create an entirely new world. So let's explore these complex ecosystems that scientists call sky islands, found 300 feet above the forest floor. Over hundreds and hundreds of years, debris, leaves, and dust all collect on the massive branches. This creates these deep, sponge-like mats of actual soil which can hold moisture and support life, effectively lifting the entire forest floor right up into the sky. And in this amazing aerial soil, a whole community of organisms called epiphytes just thrives. We're talking mosses, ferns, even huckleberry shrubs. And you also find these wonderfully named lichens like old man's beard and, I'm not making this up, fairy puke, all forming this multi-layered ecosystem hundreds of feet off the ground.
This unique habitat, of course, drives unique evolution. Let's look at the ultimate case study of an animal that has adapted to life at this vertical extreme, the flying salamander.
This is the wandering salamander. It's an amphibian, only about 10 centimeters long, and it lives its entire life in those soil mats high up in the canopy. Think about that for a second. An amphibian surviving in a place it has no business being. But living so high up comes with one major obvious risk: falling. And this is where its adaptation is just so stunning. When a normal salamander from the ground falls, it just tumbles helplessly. But the wandering salamander, it instantly adopts a skydiving posture, using its body, its limbs, and its tail to parachute and glide. Researchers who studied this behavior actually put them in wind tunnels, and they described it as having an exquisite amount of maneuverable control. It can actively steer itself back towards the massive trunk of the tree, turning what should be a fatal fall into a controlled descent. It is a direct evolutionary response to the redwood's extreme height. So when you put it all together, the crucial point is that everything we've talked about, the insane height, the hydraulic repair system, the sky islands, even the skydiving salamanders, it's all built on a very delicate balance. The survival of the world's tallest trees is completely intrinsically linked to the presence of that coastal fog. And that, of course, leaves us with a final, very urgent question. As our climate changes, those coastal fog patterns are already starting to shift. The very moisture these giants depend on to defy gravity and to heal themselves is becoming less reliable. So what happens to these architects of air when their secret weapon, the fog, disappears?